All right, let's run through a couple basics on computing with Jupyter Notebooks. Obviously, I mean, I assume since you're in this class, almost all of you had the PCDA class with me, so you use Jupyter Notebooks. And so this is at a, kind of a little bit higher level about some best practices. So first of all, give your notebook a good name. It's kind of an ongoing joke in the Jupyter community. You make a new notebook, and you end up with 10,000 Untitled One, Untitled Two, Untitled Three in your project folder. So right away, just rename it. You could just right click and rename the notebook. So give it a good name. It's pretend we're in the Linux world. We don't use strange characters, no spaces. Make it easy then to actually work with notebook file names as strings that aren't too terrible to deal with. In general, have some sort of kind of summary at the top about what the purpose of the notebook is. You might even do some other things like kind of noting where you got certain data sources, or keep a simple change log of major modifications to the notebook. It's kind of up to you. So in this notebook, we're going to go over some suggested best practices, and it's really aimed at the scenario that describes how we're going to use notebooks as we get going in this class. So primarily, as we start out, in the next module, our notebooks are primarily authored by one person, by you, and used by you. So it's kind of end user development. And for now, we'll be kind of focusing on exploratory analysis and model development kinds of things. And that our intention is not to put this into some sort of production analysis pipeline. So it really is kind of like a lab notebook. Later on in the course, we'll talk about other ways of using notebooks to support collaborative development and sharing notebooks and actually productionizing them. I list this one here as a good resource. And one is just, again, I like to call attention to the Practical Business Python blog because I'm a big fan. Chris Moffat, the author of this, has done a number of extremely good and extremely relevant posts on using Python. And in this one, he actually talks about something called Cookie Cutter, which we will be using in this course. We're going to get into cookie cutters literally in the next session. So anyway, it's a really nice post describing how his practices for notebooks, and he's an analyst. He's not developing he's not like an IT developer person. So it very much fits the same sort of use case where he's basically going from raw data to various reports. And so I highly encourage you to take a look through this. He's got a lot of really good ideas, and we'll actually touch on many of them throughout the course. All right, so some preliminaries. So first of all, in general, put your imports up at the top. And convention is that you always list the built-in Python libraries, then third-party libraries, and then any libraries that are basically your libraries that you've created. So, for example, in this one I'm importing copy, that's a built-in one, and then come the third-party libraries, a bunch of NumPy and pandas and things like that. Those are stuff that we'll be importing all the time. And then you'll see down, below. Just kind of make reference to this what if library. This is actually something that we'll be developing in this course in a few weeks. So this is a user defined library, and so that import statement is going to go there. And there's my matplotlib, inline command. I always stick it off in its own cell. And if there's a bunch of magic commands. I've included a link to a kind of the magic command documentation page, a cheat sheet for magic commands. I'll point out the useful ones for us, but there's certainly more, and you can check them out if you want. This is a slightly more advanced concept. May not make a whole lot of sense to you quite yet, but often we might be using a notebook to test out an actual library that we're developing, and we're developing the library itself in a .py file. So in other words, like this what if, there's a what if.py file actually literally, in this folder. There it is right there. And kind of a common use case is that you're getting this thing working, you're kind of using it from a notebook, and then you'll find a bug and you'll go back and then you'll make the change in what if.py, and you'll think, well, I'll just click this and it'll reload, by importing it again, but it doesn't work that way. Once you've kind of imported once in a session, it's imported. And so this is a little bit of cell magic that you can do to force Jupyter to reload any libraries if it's detected a change. So what you end up doing is that you first of all, we use this magic command that's loading an extension, and the extension's called auto reload. And then we're setting the auto reload level to 2. And essentially what that does is that if a change is detected in whatif.py, or any library for that matter that I've imported, it will automatically re-import for you. So that's super handy. So we don't have to, manually, close the notebook and restart the session and things like that. Okay. All right, so again, most of you are sure familiar with especially if you're in my class, you know that I've developed tons of tutorials that are Jupyter Notebook based, and the beauty of notebooks is that you can mix explanatory text with code. And I want to point out, I'm going to push that a little bit further and get in a little bit deeper. So first of all, this is something known as literate programming. And this is not a new idea. I mean, it was kind of introduced by one of the true giants of the computer science world, Donald Knuth, who's written kind of some very famous books. I'll take you to that site in a minute. But the idea is that we should be able to kind of mix explanatory, ordinary human language kinds of things along with source code to make our programs very readable. That's the basic idea. So certainly notebooks kind of fall into that category. If you want to learn more about Donald Knuth, it's a fascinating guy, still around, and this series of books called The Art of Computer Programming are world famous. This is one of the things that that people will say that nobody in the world has read them all, and it's just been an ongoing development like since 1968. So and he's still working on stuff. So it's kind of legendary. And Donald Knuth is also famous for he was the gentleman who developed the typesetting program TeX. You may be more familiar with, there's a set of macros that are built on top of TeX known as LaTeX, and it's spelled like that. It's not pronounced latex, it's LaTeX. And the T is capitalized, the X is capitalized, the L is capitalized. And literally many thousands, hundreds of thousands of journal papers are written in LaTeX. I wrote my dissertation in LaTeX. I published, a ton of academic articles written in LaTeX. And the nice thing is that Jupyter Notebooks support LaTeX natively, as does our Markdown document. So we saw this back in the PCDA class numerous times, and you may have poked into it a bit and learned a little bit of LaTeX. And so here is in notebooks when we want to have a mathematical expression, a LaTeX expression, and we want it to be kind of not inlined. It's in display mode, and like in the middle of the page like that. The $sign says, okay, here comes a display mode equation, and then this is what LaTeX looks like, and it's pretty readable, especially once you get used to it. Oh, I bet that's the Greek letter alpha, and then I'm going to sum from n equals 1 up to capital N. Use the Greek letter theta, and I'm going to subscript it by n and superscript it by 2. So it's theta sub n squared, and that's exactly what it is. So you should learn enough LaTeX to be dangerous. It comes in handy to document a little bit of math. And if you do it in line, you just need a single $sign if you were writing something in the middle of the sentence. So if I just here, I'll write. I'll just put it here. It makes no sense. X squared. All right. So that will be some inline LaTeX. And there it is. There's X squared. Okay. So, and and I've said this numerous times. When you're writing explanatory text, do it in the Markdown cells, not as giant comments in code cells. And you can change the type of cell between code and notebook. Code and Markdown quite easily. All right, so first of all, I'm going to insert a cell right above here, and I talk about this later. In fact, here it is. One of the keyboard shortcuts to learn is insert cell above. When you're in command mode, you press A. So first of all, well, what's command mode? Command mode is my cursor is not active in the cell, though the whole cell is kind of active right now, and so I can do commands that operate on the cell itself. And so if I do A, it'll insert. So now by default, that's a code cell. And that thing is still in command mode. There's no cursor there. I'm not editing it. That's edit mode. And so if I hit M, now it's back to a markdown cell. And if I hit Y, now it's back to a code cell. And you can also do that through this, right? There's markdown. So, just add a new cell, change it to markdown, and start writing markdown. Okay, whenever you need to explain something. Like now I'm in here, right? Now I'm typing markdown, bold, and right, I haven't executed it, so it just kind of shows like that. If I run it now, it actually renders it. Okay, so So I want you to get used to being a literate programmer, so using Markdown to write things. Couple changes in the Jupyter Lab. The latest version is version 3 that just kind of recently came out, and there's been some nice interface changes, including kind of what's available over here in the left sidebar. So I often will have the file thing open, but a really nice addition is you used to have to load a special extension to get a table of contents, and now this little table of contents thing. And this is by itself enough motivation to learn how to use Markdown, especially because section headings are then automatically picked up in the table of contents. And to remember section headings, right? That's a level 3 heading. All right, so that's a level 1 heading. Okay, so that's a really nice thing with this the new table of contents extension. And the other thing, there used to be a button over here to see all the keyboard shortcuts, and that's kind of gone now. It's a little more difficult to get at it. You can find them through the view menu. You have to go to activate the command palette, or you do a Control-Shift-C, and then you have to kind of search for the command. I use a handful of shortcuts all the time, so I know them. And then also I've included this link to this cheat sheet, which is nice, and we'll take a look at that. So, for example, in the notebook cell operations, I'm just going to scroll down. We talked about insert cell above is A and insert cell below is B. I use those all the time. And changing the cell type, from code to markdown, and there's also something called a raw cell type, which I don't think I've ever used. So just knowing these two. Oh, this is kind of cool too. I actually haven't used this, but you can use the numbers to change the cell headings. And again, so you have to be, like, let's say if I was editing that thing, I have to be in command mode. Well, actually, you know what? Let me run it. It's better. So if I select that and now I hit 2, notice it changes it to level 2, and now it's level 3. Now it's back to level 1. And whatever I run it at, I'll put that there, right? And then also, you don't have to use the run. You should try out all the different versions of entering. So obviously I can't hit enter because that just gives me a line return, and that happens the same thing in a code cell as it does in a markdown cell. So if I do control enter, notice it will run the cell and leave you in the same cell. And if you do shift enter, it runs the cell and takes you to the next cell. And let's go to the very bottom. So let's say I was down here and I said, print hello, right? And so now what happens if I do a shift enter is it runs it, and if there's nothing, it will create a new cell below it. So now let's see what happens if I do the same thing here. I'll do x equals 1, right? So shift enter will run it and take me to the next cell. In this case, since there was no next cell, it opened up a new one. If I do an alt enter, it will run it and then insert a blank cell below. So kind of the combination of Control, Alt, and Shift can get you through the various behaviors you might want as you're working with notebooks. And again, you can always still just go up and hit Run and move yourself, but and again, a couple of the ones to really know for sure are the A and B for inserting a cell above and below, and then I just worked through those, and then take a look at that cheat sheet for more. This Jupyter Notebook versus Jupyter Lab. This is a relatively newish thing, but Lab's been out now for a couple of years. And in fact, in the PCDA class, I've been using Jupyter Lab the last 2 semesters. And in fact, in that class, I did a screencast on comparing the 2 interfaces. And in fact, this screencast right here is from the PCDA class. So it'll be the virtual machine. And I'm sure that'll be familiar to you if you took the PCDA class. But I do a little thing of walking through the difference between notebooks and labs, and Jupyter Lab. So I encourage you to take a look at that. Nice post about the overview of the evolution from Jupyter Notebook to Jupyter Lab. And you can still use the notebook interface, but Jupyter Lab is really kind of the standard now. This is a nice post. I like it. Good, very brief and to the point. Okay. A couple more things on kind of the basics. Again, I'm assuming you're already familiar with the basic because you're in this class. Lots of tutorials out there. Chapter 1 of the practical the Python Data Science Handbook by Jake van der Plas covers the IPython shell and Jupyter notebooks, and a lot of the techniques work both in the IPython console or shell as well as in the notebooks. A lot of the tutorials that you find on the web are of the classic notebook interface, but you'll see that changing as Jupyter Lab becomes even more established. And again, a lot of the concepts carry over. And I still sometimes use notebooks. Sometimes, especially, there are extensions that don't play well yet with Jupyter Lab, so you have to use a notebook interface. And again, if you like presentation, there's a nice PyData from 2018 presentation on the evolution of the notebook if you want to, take a look at it, but certainly not necessary. The notebooks, not surprisingly, actually have gotten huge adoption in the scientific community, and so then people started to try to get people to use notebooks, use them well. And there was a nice article that came out in Computational Biology on 10 simple rules for writing and sharing computational analysis in Jupyter notebooks. So I encourage you to actually take a look at the article. It's short, it's really good, and I've kind of paraphrased the 10 rules. And also I want to point out one of the authors is this guy, Fernando Perez. If you're going to work in notebooks, you should know who Fernando Perez is. And he's the guy who literally created the IPython notebook. And it's a great story. If you've already gone through the Jupyter Notebook history, you learned more about Fernando Perez. I mean, he was a grad student when he developed this, so it's pretty amazing. So here's the 10 rules, and I think a really big one is just, again, pretending you're telling a story to somebody. I always try to take that perspective when I'm creating tutorials for class. It's really easy to kind of just skip over the process and just kind of have the results show up, but document why you're doing certain things. That's really important in this class, and it's really important for yourself when you go back and look at notebooks. You're like, well, why did I do that? So I'd rather have you be overly verbose. Breaks don't have giant code cells. The whole point of notebooks is to kind of have small code cells, get little pieces working. And again, this is different than developing, production software. We're not doing that right now. We're really using this in a very exploratory way, and we're the primary user. It's kind of very, this Rule 3 is similar to Rule 4 in the sense of, of modularizing things. Even if within a notebook you find yourself repeating code, stick that code into a function and have that function be defined in the notebook and call it, from there. And then you'll see as we go through one of the sessions of the class, we'll develop some things and we'll say, okay, it would make sense now to modularize this. Let's put it inside an actual code module that we can import. It's always easier to find problems with smaller pieces of code. And it's also easier to find ways to reuse things when they're in small modular pieces. We're going to as soon as we start sharing notebooks, you start running into issues with dependencies. What libraries, what versions of libraries. So throughout this course, we'll be using Conda to install new libraries, and you'll see we'll start to learn about dependency management and how to make it easy for other people to use our work, especially with notebooks. Version control, even though there's definitely some challenges with using notebooks with respect to version control, really because notebooks, when you save them, they save the current state of the output cells. So it can be, you could have a notebook that you've made no changes to, but from Git's perspective, it thinks you've changed things because you happened to run some cell last time and you didn't run it this time. So even just a simple thing of always clearing your output and saving before you, every time when you quit, and then it's easier to version control the notebooks. I mean, it's easy to put them under version control. It's just that you end up sometimes with, Git telling you that something changed when you haven't made any changes to the notebook. Once you understand that, it's really no big deal. There's actually specialized tools that are kind of popping up. That also does make it challenging, though, when you're trying to merge notebooks, with multiple developers, or merge changes. There's some specialized tools that people are creating to help deal with this issue. One is called NBDime, and we'll learn more about those later in the course. This idea of building a pipeline is think of where your notebook fits into any sort of longer analysis chain, and try to make it play nice. And one of the one of the things that kind of goes along with this is, the notebook itself. These were designed to flow computationally from top to bottom. So it can be easy to kind of really get yourself into a pretzel by, you know, redefining something up above or rerunning a cell up above some other code, because the notebook kind of just knows its current state. And this is one criticism of notebooks, especially when they're used for people who are beginners. They're not used to maybe thinking about the implications of things like which order I run the cells in. But if you always just kind of remember, these things are designed to be run from top to bottom. And even when you're building a notebook, we'll often want to do this: restart the kernel and run all. In other words, hey, clear all the stuff out of memory, rerun everything from the top. And you'll see there's actually, you can do things like restart the kernel and clear, run. You can restart the kernel and run up to a selected cell, restart the kernel and run all cells. It's kind of similar to, in the PCDA class when we were doing R, and you were, and anytime you knitted an RMD file, it was doing that, right? It wasn't using whatever objects you had in the working environment in R. It was clearing it out and rerunning everything and knitting it from scratch. And that's kind of the way the user practice that we need to develop when we're using notebooks. The data itself, often we'll be reading from CSV files or maybe from a website, and sometimes this can be challenging to, you should certainly document where you're getting your data from, but when it comes to sharing it, we'll see, various solutions in terms of, putting the data sets in publicly accessible places. And if it's small enough, we can sometimes just keep it right in our GitHub repo. And kind of an overall thing of it's kind of like writing a book, except that it's a book that you can actually explore and change things as you're going through it. And so think about designing your notebook that way. You want somebody to be able to read something, not just run code and just kind of run one cell, run the next cell, but to explore a bit. So you try to design things either by asking questions or putting the way you design your code so that people can kind of easily play with things and say, hey, well, what if I change the value of this parameter? What happens? Okay. And this open source community is a really great community, and there are lots of really good tools have been developed. So remember that all happens because everybody has to kind of give back to the community to make it all work. So be an advocate for things like open research and open source software. All right, so I'll end this little thing with just a quick example. So, as you've seen, I develop lots of tutorials for my HSD Lab blog and for my class. And this one that we're actually going to explore later in the semester. And so I encourage, in fact, that is this notebook right here. So I encourage you to kind of take a look through that. And I actually put together a little short screencast that kind of hits some of the highlights. Again, the point isn't to go through the details of the notebook. It's to take a high level view and see how, I try to use these rules as I'm going through and developing the notebook. But I also wanted to end this with just kind of a really common thing, and that is images. Okay. So there's multiple ways to include images in notebooks. So if I double click this markdown cell, this is the markdown syntax for including an image. So it's an exclamation point, and then in brackets, this is your alt text, right? So if the image was missing, this is the alt text that would show up. So we always have alt text. And then again, no space. It's just immediately within parentheses is the file path to the image. And notice it's not quoted in this case. Okay, Markdown, you don't quote this in Markdown. And that works fine, except if you do a file export notebook as HTML, the images will not show up when they're done that way. And I remember researching that, and so at this point, it just doesn't work. So another way to show images is actually to use a Python library. There's a module called display that's within the IPython library itself, and the function is called image. So if I import that, now I can run the image command, and notice now my file path is quoted. Okay, so it has to be here, and so I can run that, and then it will load the image. And if you export to HTML, that image will actually be there. Okay, so this is just kind of some higher level suggestions for becoming an effective Jupyter Notebook user.